Hello, 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 everyone, and welcome. Welcome, everyone. So for those who are all the way in the back, I want you to come in and fill these seats. Continue your that's right. Finish your conversations. Make sure, don't worry, at the end, you're going to have time to get everyone's LinkedIn information. Thank you, thank you, thank you. All right, everyone. So it's a pleasure to meet all of you. My name is Nia Macklin. I am a senior developer advocate here at Neo4j. And we together are so excited to join for this meetup, this Context Graph Meetup. Now, has anyone ever been to a Context Graph Meetup before? No, that's right. We are hosting the inaugural Context Graph Meetup here in San Francisco. Woo, woo, woo! Love it, love it, love it. So today, everyone, you're going to hear from some deep-seated research from some of the most prominent experts in context graphs. People who've been doing this work for it's not generations, but I'll say decades, okay? But people have been doing this work for a long time, right? Context graph is actually not a new concept, but we're going to get into that. So first of all, I want to introduce our first speaker of the day. His name is Will Lyon, and he is a senior product manager on the AI innovation team, and he is going to start off our conversation about context graphs. Come on, Will, give him a round of applause. Woo! Thank you.
Intro. Are we good on the mic? Yeah, there we go. I hear it now. Cool. And I don't quite see my slides. If we could switch to this guy, that'd be great. So yeah, so like Nia said, my name's Will. I'm a product manager at Neo4j. I work on the AI innovation team. So we spend a lot of effort making sure that Neo4j remains the best graph database for AI use cases as well, and so that's what my team focuses on. You can find the slides, graphstuff.com/CG Meetup, Context Graph Meetup, or the QR code there. So there's been a lot of great discussion around context graphs. This really bubbled up and resurfaced, I think, after Foundation Capital put out this post about context graphs are a $1 trillion opportunity for AI. There's a really good context graph paper from a couple of years ago. And there's been a lot of discussion about what's needed for context graphs, the challenges, and a lot of good discussion around it. I think what's common in all of the discussion around the context graph topic is it's all about this idea of the missing why, right? So that if we have an agent, recommends making a credit approval decision, we need to understand, why? What is all the data that goes into that decision? And this isn't just about AI agents, right? Fundamentally, a context graph is a knowledge graph that contains all of the information necessary to make decisions throughout the organization, right? And so we may keep these in a audit log, which shows, okay, this is the, line by line, we rejected this transaction. But why? What are the specific pieces of the, policy that went into this? This may be stored across lots of different systems that we need to sort of combine together and query across in one knowledge graph. And that, to me, is fundamentally what this idea of context graph is all about. So let's look at maybe an example in the financial services world. How many people here work in financial services? I'm just curious. A few. Okay, not many. Yeah, this is San Francisco, so makes sense. So if we think of okay, what's the data model that we might need for a context graph for the financial services world? Well, we're going to have people, like we're going to have people that have accounts at our bank. There's going to be transactions. These are the events, right? So transactions are what happened. Entities, the people, the organization. These are the things. And then the context, the why, we're modeling these as like decisions, policies, these sorts of things. So let's take a look at an example. This is online. You can run this context graph demo, Vercel.app. We'll take a look at it. So this is a demo app that I put together because I saw all this great discussion about context graph this and context graph that, and we could do this, we could do that, that'd be really neat. And I'm like, yeah, okay, cool. Like let's try to take something that looks a little bit real and see what we can come up with here. So this is the data model. We have this data loaded in Neo4j, very similar to the slide I just showed, but a bit more complex, right? So our decisions, they apply a policy, but decisions also serve as a precedent, right? So we have relationships that connect our decision nodes as well, and we also have some additional information like alerts, support tickets, this sort of thing. So just a little bit richer data model. And so we can think of this as, let me zoom in as much as I can here. So think of this as like what, I don't know, an analyst at a bank might use this sort of tool to respond to customer requests, that sort of thing. So this is a context graph agent. So we're saying, hey, we have a credit limit request from our customer, Jessica Norris. She's requesting a $25,000 limit. And we can see here, if we inspect the details of our agent has lots of tools. These are all tools that we've defined how to interact with our context graph. And of course, it has a system prompt. You are a helpful agent that knows a lot about financial services and so on. And then we have the tool calls, right? So tool calls are the way that an agent interacts with and understands its environment. And we can see here all the tool calls that this agent makes to fetch the data, to fetch the context that it needs to make this recommendation. And we render all the pieces of that in a graph, right? So we can kind of see the different people, decisions, policies that were implemented here. We can like double click and traverse out through the graph to get more information for our analyst. We can also look through the causal chains of decisions and so on that led up to this. And ultimately, we get a recommendation from the agent. In this case, the recommendation is conditional approval and says, hey, do you want to record this decision? Great, yes. Record this in the context graph, and this will update our graph, adding another decision node that will then serve as precedent and so on going forward. So again, you can feel free to play around with this online. The code is open source. There's a blog post that explains how it works as well. Now, if we look at what's actually going on here, how is the agent tracing this decision history to make this recommendation for it? How is it using this context graph? Well, the first thing it does is it searches for the customer, right? And then looking for the context around that customer by traversing the graph and finds, oh, well, this customer had a previous fraud flag. We can then use hybrid search, so combined vector and graph search to find the most relevant precedents and ultimately make our recommendation. This idea of hybrid search, combining graph and vector, by the way, I think is really important and really powerful. Neo4j has tooling called graph data science, which allows us to run graph algorithms like centralities, page ranks, or here we're talking about graph embeddings, in this case the FastRP algorithm, which is a way of generating and embedding not just on like the content of text, right? So if you're familiar with text embeddings and maybe storing those as vectors and doing vector similarity search, right? That helps us to find, in this case, decisions and policies that textually, like semantically, are similar. But what about the structure? And that's where things like graph embeddings come in. We can actually look at the structure of a account's relationship to the way it maybe interacts with transactions, other accounts, these sorts of things, the fraud patterns that we see. These can also be used to generate embeddings, and then we can use similar vector search functionality that we're familiar with to find the most relevant data for our context. So there's a little bit more about what's going on in the context graph demo, some of the other graph algorithms that are used, some of the tools, sort of a resource for later there. So that's all fine and good. Like we saw like a nice agent chat. We saw how it can help us make decisions and apply policies. Like that's great, but how do we actually build one of those, right? And this is one of the bigger challenges of making use of a context graph is how to actually capture these reasoning traces. And so at Neo4j, we've built a Neo4j agent memory Python package that allows you to add graph-based agent memory to your agent, and we have integrations pretty much any agent framework. But I want to talk about kind of how we think of the relationship between memory and a context graph. So Neo4j agent memory, this is an open source Python package that you can install and leverage. Again, lots of different framework integrations. We'll talk a bit about entity extraction, because I think this is an important piece of the agent memory package. So there are sort of 3 high-level abstractions of the type of memory that we're working with here, and I think they're all needed for the context graph, right? So going back to this slide, like context graphs need short-term memory, long-term memory, and this reasoning or decision traces, right? Like the decision traces and the auditing, like, okay, that's obvious why we need that. It may be less obvious why we need short-term and long-term memory as well. So short-term memory, this is conversation, session state, like working memory, think of it like this. When we're using the Neo4j agent memory package and we save a message, this kicks off a background entity extraction job that's kind of like moving us from short-term to long-term memory. And so we're looking for all of the entities, all of the connections between entities, the facts. We're extracting that from unstructured message data and loading that into the graph. Now, there are several other agent memory systems that have this concept of entity extraction to construct the graph. One thing that I realized, or we realized when we were building this, it's really important, is not just using LLM-based entity extraction. This is very, very slow and very expensive to send every message to the LLM and say, hey, what are the entities? How are they connected? And so instead, we have this pipeline approach where we start with some of the more probabilistic statistical methods like named entity recognition, the things that are available in like the Spacey Python package, if you're familiar with that. Then we use things like Gliner2, which is a local model that is a pretty small model that we can run on CPU for specifically fine-tuned for extraction and entity extraction and also relationship extraction, which is quite nice. Then we only need to fall back to the LLM. So that's built into this package. I think that was quite important for handling large amounts of conversations. So we talked about this entity extraction process. One thing that's important in entity extraction, in addition to like not just relying on the LLMs to do that for cost and efficiency, but also the data model that we use for entity extraction is really important. It's really important that the memory that we are saving to the graph is relevant for our domain, right? Like if we're financial services, we should be making sure that we're saving financial services related data and not unrelated things like, I don't know, where someone's kid went on vacation, or I don't know, whatever's in there that might not be relevant, right? And so by default, we use this POL, people, organization, location, event, plus object, so POL plus O model. If you're familiar with POL, it's used a lot in crime investigations and this sort of thing. So this is the default model that we use, though. So you have the ability to apply your own domain model, and those are the things that are then extracted out. Like this I think is also really important for agent memory. And the third piece here is the reasoning memory abstraction. I think reasoning memory is one of the more important pieces for building context graphs. And I think it's this piece that we actually don't see a lot of support for in a lot of the AI agent memory frameworks that are out there. When we're talking about reasoning memory, this is, you may hear terms like procedural memory is another one that's used here. So you can think of this as kind of like procedural memory with a little bit more to it. So this is recording like the tool call traces that we make. These reasoning decisions are stored in the graph as well, right? So short-term, long-term, reasoning memory. These are the APIs that we have available in Neo4j Agent Memory for not just constructing your context graph, but also like searching it, finding the most relevant context, assembling that for your agent. So when you combine these all together, short-term, long-term reasoning memory, this is all one connected graph, right? So short-term memory are conversations, entities extracted from those conversations, and then reasoning traces, tool call, reasoning steps. Those are connected to the messages and the entities that are retrieved for the context, right? So now that we have our memory in one graph system, we can query across data from all these systems. Here's what this looks like. This is an example of hitting the three different types, right? Storing a short-term conversation, searching long-term memory, and then recording a reasoning trace. So there's another example that I'm going to touch on just quickly here. So this is another demo app that we built. It's online. The code is open source. How many people are familiar with Lenny's podcast? It's like a popular tech products kind of podcast. So we took the transcripts from Lenny's podcast, ran that through the Neo4j agent memory as if it were like a agent conversation, and sort of constructed a context graph from that. And so we can do things like ask, what are all the locations mentioned? So in the Brian Chesky episode, Brian Chesky is a co-founder of Airbnb. And so we can, we automatically geocode and then enrich the locations that are extracted, right? So Bolinas is mentioned. I don't know, Brian Chesky owns property there. I don't know. I didn't listen to the episode. But then it's enriched by data from Wikipedia, right? And RISD, that's the Rhode Island School of Design, where Brian Chesky went to school, right? And so I guess what I'm just trying to point out here is there are other types of information in the graph as well that we extract, not just like textual data, right? Like here we're working with geospatial data, and this concept of enrichment, I think, is also really important. Cool, so I'll skip maybe going through more examples of that to talk about just kind of the architecture of the Lenny's memory example. We go through this entity extraction to context graph construction, and then we're able to create agents that are able to interact with that context graph. One thing that might be interesting, let's take a look. So this Lenny's memory app, so this is running publicly. We can see all the previous questions that folks have asked. This is what folks are asking publicly out there, right? And what we do is we record and write back to the graph the reasoning memory from everyone's interaction with this agent. So I have this running in Neo4j Aura. This is Neo4j's cloud service. So if I go, I think it's this one. And if we open up Neo4j browser, so this is the query workbench for Neo4j. And so we can see here, we can see the entities that were extracted in the episode and kind of query that way. But I want to let's look at our reasoning traces that we've recorded. So here's a reasoning trace that has 2 steps. So each step is a tool call, and we're recording the tool call result. We're recording the number of tokens used, the response, and so on. And this becomes the basis for the reasoning memory and understanding the traces that our agent is taking. Cool. So anyway, a little look at what that looks like in in the graph. We've been doing some integrations with lots of the different agent frameworks. This is a look at some of the cloud vendors with agent frameworks that we've built integrations with the Neo4j agent memory package with. And these agent frameworks are like Google ADK, AWS Strands, or Microsoft Agent Framework. They all have their own sort of like memory abstractions. And so we wire those up to Neo4j agent memory, and then we publish a specific integration for those packages and make sure we support their models and running on things like Vertex if we're looking at ADK or Bedrock if we're talking about AWS. Also some other functionality in some of the releases like MCP, OpenTelemetry support OPIC as well if anyone's using that. Another interesting demo app, I just want to leave this as a resource. There's an agent swarm version of this financial services demo. So if you want to see what it looks like to have a bunch of different agents with different personas, maybe we have a anti-money laundering agent, a compliance agent, a customer service agent, and they all have a shared memory layer. So I thought it was really interesting to see what does this look like if we give, not just a single agent, but across, all of our agents are both contributing to and understanding, fetching context from a shared Neo4j agent memory layer. So that one's quite interesting if you want to check that out. Just a link of some resources. How many folks are registered for Nodes AI in April? Okay, that is like 10%. That is not nearly enough. Everyone needs to scan the QR code, register for this right now. Nodes AI, so Nodes is Neo4j's online conference, the Neo4j Online Developer Education Summit. We do this in the fall, but we've just now started an AI version of this. So this is really fun. We're going to do workshops leading up to this as well. So definitely register for Nodes AI. We'll be giving lots of talks about context graphs and lots of folks from the community sharing what they're working on as well. Cool, so that's all that I have. You can get the slides with the QR code or that link. We're going to save questions for the end. All the speakers, plus Emil, who's in the audience somewhere, is going to join us for a panel discussion at the end. So we'll save questions for that. So that's it for me. Thank you very much.
Thank you so much, Will. Okay, everyone, so next up, we have a very special guest as well, Ms. Jessica Talisman. And for those who don't know, has anyone heard of this incredible person before? Okay, I see hands, yes. So for those who don't know, this brilliant, brilliant architect. So Jessica Talisman is an information architect, all right? Information architect, a semantic strategist, a lifelong student of systems, meaning, and human understanding. And for over 25 years, she has worked at the intersection of knowledge, of frameworks, of digital infrastructure, and helping both large organizations and cultural institutions build information systems that support clarity, interoperability, and long-term value. So we are thrilled to have Ms. Jessica Towson join us today for a conversation on context graphs, and context specifically is knowledge. So before we get started, because I see things are still developing over here, what I want you all to do is to, we actually are ready to get started. All right, so next time I'm going to have some networking questions for you all. All right, so let's give Jessica a round of applause, everyone. Thank you.
Thank you so much. So it's been quite a whirlwind in, less than 2 months, we all of a sudden have context graphs. And so it just so happens that around 3 months before the context graph article published, I had been doing research and written a paper about process knowledge management. Not sure if many of you have heard of that, It's process knowledge and procedural knowledge, which is essentially context graph. So I will be a little tongue-in-cheek about this, because when we say context graph, it's like saying wet water, because that's the benefit of graphs. But I have been working for about 25 years in the semantic space, specifically with knowledge graphs. I'm a librarian by training, informatics, and also teaching. I've worked in enterprises for the better part of 25 years, but I've also spent some time, thankfully, in GLAM, cultural institutions, which I think is a nice offset and balance. So let's get started. In December of 2025, Foundation Capital published an opinion piece, mind you, a blog, that sent ripples throughout enterprise software circles, and the title alone did the work: Context Graphs, AI's $1 trillion opportunity. So the argument was clean and seductive, the single most valuable asset for companies in the era of AI. It was the $1 trillion and still is postured as the $1 trillion opportunity. So the argument was clean, it was very seductive. Enterprise systems like Salesforce, Workday, and SAP have spent decades recording what happens, so decision traces are not new. The one thing that was interesting that kind of changed the trajectory, at least from my vantage point when I started examining the blog, there were no proofs of concept, there was no explanation of how this is done, there was no demos, which was a wonderful opportunity for the entire technology industry to basically have fun, have a play day, start to innovate, start to decide what this means and how it should manifest in a system. The quote, "the single most valuable asset for companies in the era of AI," left a lot of room for creativity and a lot of opportunity for new products to emerge. So they named the problem, and it's a problem many of us have been facing, and I agree with the problem. The urgency is there. And what I want to challenge tonight is the solution, because the framing Foundational Capital uses carries a hidden assumption that if left unchallenged will cause every context graph initiative to fail for exactly the same reason that most AI initiatives have been failing. And that is mostly, just to put it into your ear, that this is a knowledge management problem. It's not something that it can exist in isolation, it is a knowledge management problem. The hidden assumption exists in a single sentence, and let me read it to you carefully. The wall isn't missing data, it's missing decision traces. That sentence sounds like a solution, and most of us took it as a solution, that decision traces are the solution, but it is in fact a misdirection, because decision traces are not data. Decision traces are knowledge, or part of knowledge. As we just saw in Will's demo, he had to connect the decision traces to other context, other meaning, the actual knowledge within a system. I thought that was beautifully presented, was it could not live or exist in isolation. Capturing knowledge is not an engineering problem that you solve by instrumenting an orchestration layer. It is a knowledge management problem, one that requires entirely different methods, disciplines, and infrastructures. I'm going to show you where the context graph thesis is right and where it goes sideways and what the actual foundation needs to look like, drawing from Process Knowledge Management series and some of my ontology work that I've been doing in the process. So the straw man, we're going to work this out in terms of, to understand the argument fully, is there some things that the argument has correct? Yes, current state systems preserve the outcome, not the reasoning. And I think Will also just presented that. You can't replay the state of the world at decision time. We can agree. Warehouses are in the read path. We can agree. Agents have structural advantage because agents sit in the orchestration path. We can agree. The claim I'm challenging is that it's not a data problem. It's not a data problem and it's not an orchestration problem. It is a knowledge management problem. And this came through in my research and work with the Procedural group, with the procedural and process knowledge management work. Something has to define what a decision is. Something has to model the entities, the relationships, the roles and exception policies and conditions that give a decision its meaning. That something is not a database. It is a knowledge model. That's why we call it a knowledge graph. Here's the claim I want to put in front of you directly, which is Foundation Capital says it's not a data problem. I say it's not a data problem, and it's not an orchestration problem. What I'm posing to everyone in the room is that it's a knowledge management problem. Context is not the same as data. Context is meaning derived from relationships. So when a VP, I think this was in the essay, when a VP approves a 20% discount that exceeds policy by 10%, what makes the decision comprehensible? Well, obviously you would need the facts that surround that decision that makes that thing true. And that's what we see with ontologies and knowledge graphs. So we don't get this simply by capturing a logged event or by logging an event. It is captured by having previously defined in a structured way what customer tiers exist, what policies govern discounts, what roles exist in approval hierarchies, what outcomes are possible, and how exceptions relate to precedents. So I'm not sure how many of you have heard of Polanyi's paradox, which is we know more than we can tell. And the thing, I wish this microphone were portable, guys. I'm like trying to walk away from it, but I won't. Tacit knowledge, the thing about tacit knowledge is that it's something that exists in people's heads. And I've joked that we would have to employ Neuralink for us to in fact capture tacit knowledge, because once knowledge is recorded, it's no longer tacit. That's just a social condition. The thing about knowledge management also is that knowledge management is also a very social process. It invariably involves humans. So if we're going to make decision traces queryable, if we're going to make precedents searchable, we need to do three things that Foundation Capital's framing does not account for. So it's called knowledge elicitation, which is the elicitation of tacit knowledge that, oh, thank you. That, is it on? Yes. That is the elicitation of tacit knowledge that determines a decision, even what a decision is. Thank you, and what makes it meaningful. So the idea is to organize and to encode this knowledge in a meaningful way to create the relationships and connections between things. So we need to encode it in a formal representations that computational systems can in fact reason over. So the interesting thing when we look at context is a lot of context, and again, we saw this in the demo that we just witnessed with Will, is that context and meaning are derived from relationships between things. That's just the nature. It's the space in between, the negative space between nodes, the ideas of how things connect, and those decisions. So the types of things that we see, event logs, facts, without structure, that can fit into sort of the data column. When we look at knowledge, we're modeling facts with relationships and we're applying formal definitions. And when we get to context, we're deriving the meaning from the relationships over time. That's where the context comes into play. So when we look at how we can architect and engineer process and procedural knowledge for context to derive context, in my series, my process knowledge management series, I broke this into three layers. One is strategic. So there is an actual act in knowledge management, in the elicitation and the recording of knowledge, where we question, why does this process exist? What value does it create? Because we have to actually define what we're modeling. That's just practical, that's pragmatic. The second is tactical. We look at bottlenecks, resource allocation, exception handling, and optimization. So that's the tactical layer. And the third layer is operational, which was most of the focus of Foundation Capital's thesis and most of the focus of most context graphs that I'm seeing is the operational piece. It's the top layer. So again, we are jumping to the final result rather than doing the work that's necessary to actually encode this as knowledge so that we can build resilient systems. So the pragmatic aspect of context graphs is that there's no way that you can query what you don't understand. There's no way to query what you haven't represented formally. And there's no way to query across systems, especially when you have multiple workflows at play. It's not one size fits all. That's just a matter of fact. We've experienced this before. It's like Groundhog's Day. We've been here before with other systems, and here we are with AI systems, again, hoping that we can magically render knowledge with the help of AI systems. And this, fortunately or unfortunately, involves humans in the loop. So I'm sort of rushing through this so that we can save time, but what does a knowledge infrastructure look like? And this was so interesting from my research with the Cephreal group and with the procedural knowledge. So this was a 3-year-long project, and they actually have white papers and peer-reviewed papers, and formally these things are not called context graphs. The paper that Will brought up was a knowledge graph, but it wasn't context graph in the traditional sense as we know it now of recording decision traces. Traditionally in knowledge management, context graphs are in fact known as procedural knowledge, but that doesn't sound as sexy for marketing, so we'll go with context graphs. So with procedural knowledge, you're documenting procedures. This is a representation from the PKO, which is the procedural knowledge ontology. Most people are allergic to the word ontology. You could transform something like this into a schema if you're working with relational databases. Either or, the most important thing is that you have a methodology for actually recording the different stages and processes of knowledge. So we know, and this is the most interesting thing about procedural knowledge, is there's a before and after. So before things are recorded, that tacit knowledge that we talk about is in fact called process knowledge. Once it's recorded and no longer tacit, it becomes procedural knowledge. Process knowledge becomes procedural knowledge. In so doing, when you're organizing the raw material, when you're collecting or eliciting the raw tacit knowledge from people's heads, remember we're extracting it from people's heads, is then once it's recorded and it's encoded and organized and it becomes that encoding layer as ontologies, that's when we have the proof point, which is the procedural knowledge ontology, which is able to capture every single step in a workflow from execution traces to decision traces. The one thing that came true from their research, and this was for their peer-reviewed research and studies and white papers, they did a large-scale study with Siemens and their electric grid. And they were able to document across a very complex electric grid system across their factories to determine down to the millisecond when a system needed to switch over from one grid to another. That was one of the outcomes. Another one was with Belco in the EU, which had to do with lockout tagout. And that happened to be one of my favorite studies and papers, because when you actually bring procedural knowledge and context graphs into the real physical world, the story changes. When people's lives are at stake and you actually have procedures and processes that are with AI assistance, by the way, all of the things in the PKO research was with real industrial experiences and systems. So when actual humans' lives and well-being are at stake, you really see the impact of something like this system, procedural knowledge. So through the research, what came out with Beko, Fager, Siemens, and through the EU for their own internal systems, what they found was that 70% of their data analysis, this is specifically with Bosch, with their knowledge graph and with the procedural knowledge, that they were able to save about 200,000 euros a year. And this was simply by documenting these workflows, but the key was not simply creating what we call decision traces or the procedural knowledge or the context graph or that simple stream of data of the reason what and why these decisions were made, but it was actually having that knowledge encoded and represented formally within systems so it could be drawn upon and expanded upon, maintained throughout time. So when we look at how we can ground these, this type of system, the idea of a context graph, how we can take that into the real world and actually implement something that's that's reliable, the one thing that I suggest, and perhaps that's why I'm here, is to actually look at the prior art, to look at the research that's already been done, to realize that this is an established domain of study, research, and practice, that this idea, this concept has just not emerged out of the blue. It's something that we're kind of losing in this age of AI, where we are losing the citations, we're losing the prior art, we aren't standing on the shoulders of giants. And that perhaps is one of the greatest opportunities of context graphs, is actually being able to draw upon the expertise that has existed for years, the research that has existed for years. So there's 4 things that I think personally that organizations need to do. The first is to acknowledge that it's a knowledge management problem, because without realizing it's a knowledge management problem, then we're just going to be collecting streams of data and hoping for the best. So there is that factor of needing to manage our own knowledge, and I feel like that's the elephant in the room we've all been avoiding. It's hard work to manage knowledge, to keep your documentation tagged, to be able to organize things and label things and describe things and define things. The next is to build, to invest in elicitation infrastructure. So we talk a lot about wanting to automate everything, and that somehow we're just going to manifest knowledge out of systems, but in fact, there's a human factor to this. And so part of that is involving humans in the process and recording that knowledge. So that's the second part. And there's methodologies in my papers that tell you how to do that, and it can be quasi-automated. The third is to build the knowledge model before the persistence layer, and that's critical. So you define what a decision is in your domain. You model entities, roles, conditions, policies, and this becomes part of your ontology or your knowledge representation. So don't put the cart before the horse. And the fourth is design for knowledge capture as a primary objective. So things like building prompt libraries. That's something I don't see a lot of people doing. Central registries, formal representations. You make the entire AI proposition about process, procedure, and knowledge. Not just decision traces, execution traces. You ground it in fact. The other thing I'm asking is that, yes, the framing is beautifully simple. It's beautifully simple and very enticing. But when we actually get into the work, and I think we're going to see this with later presentations, there's a lot more involved. So when we look at what actually procedural knowledge entails, elicitation, defining, building, engaging the humans, and realizing that context is not a technical problem, it is a knowledge problem. That's why they're called knowledge graphs again. It's knowledge management. So I'll leave you with this, and this is, I indulgently included my own quote from my paper, one of my papers, which is, you cannot manage what you do not understand, and you cannot understand what you have not bothered to document. This is normally considered the boring stuff. I think it's the most exciting stuff. Because it's the way you become intimately familiar with your business. It's the way that you really understand what you're building, and it's the way that you can derive value from the systems that you build and that you present to AI. So, in my opinion, it was never boring at all. And that's it. Thank you.
Thank you so much, Jessica. That was incredible. And we're so appreciative of being able to have an honest conversation of context graphs. So next, everyone, and we want to make sure that you all, so we have this talk and then one more talk, and then we're going to have a very special panel at the end of this conversation where we're going to have a special guest join us up for this panel. So you're definitely going to want to stay for that. But in the meantime, I just want to introduce our next speaker, who is Dave Bennett. And Dave Bennett is a senior solutions engineer with IndyKite. Has anyone heard of IndyKite before? Okay, you got a couple hands. Love to see it. Awesome. Okay, so Dave himself is actually an expert in identity management. And he's focused on all the aspects of identity management projects ranging from product selection to implementation. So he's today going to present on context graphs as the control plane, right? As the control plane for your agentic enterprise. So he's going to dive into how context graphs can use AI as rich context and embedded control, which is required to govern every action in real time, ensuring precision, traceability, and operational trust at scale. So we're about to get started here. Dave is going to join us. And in the meantime, while he's getting started, and he's probably going to beat me to it, as he always does, but we're going to get started, and everyone, a round of applause for Dave. Woo!
All right, Jessica didn't want the mic, but I'm anchored to the desk, so. Thanks for coming, everybody. My name is Dave Bennett. I'm a solution engineer at Indikite. I'm going to be presenting to you on context graphs as the control plane for the agentic enterprise. So what I'm going to do tonight is I'm just going to burn through a couple slides pretty quick and then jump into like a reference architecture for what I'm talking about and then show like a little demo. So here we go. So at Indikite, we believe that context graphs are a great way to organize multi-agent systems. So we think that it's important to decouple the agent intelligence from the agent governance. So decoupling allows enterprises to change layers without rebuilding governance every time. New agents can be introduced without fragmenting data access and policies. As the stack evolves, architecture remains flexible enough to evolve. It's not just enough to have data, now we need to operationalize it. And I think this is kind of where we're going with like Jessica and some of Will's presentations. But in order to make AI deployable with the least amount of friction, we need to up our game in the control layer. Traditional knowledge graphs encode facts as triples. Employee A works in department B, but context graphs add provenance and temporal validity. And additionally, as you've seen, decisions can be materialized in the graph in a way that makes them easy to query. And this is the essential sort of je ne sais quoi of the graph and why the decision trace makes so much sense in the graph. You can trace that lineage back through many decisions. The context graph is dynamic control plane. We're moving from static permissions to dynamic intent-aware governance. Context graphs give us the capacity to explain why or how something occurred or in what sequence something happened. If agents don't have fixed roles, they execute tasks that vary by user intent, data sensitivity, environment, trust signals. In the Indikite knowledge-based access control, we evaluate all those things at runtime, not just a static role label. So at Indikite, we see context graphs not as a nice to have, but the control plane for the agentic enterprise. Without it, safe deployment's not possible. Agents need grounded, traceable decisions to handle complexity. We're bridging the gap between embedding trust directly into the graph, real-time authorization, provenance, identity verification, fine-grained access control. Okay. So the world we see today is fragmented. There's no clear view of which agents exist, and this is the enterprise world I'm talking about. These are the people that I talk to every day, and they're like, okay, we want to do all these things, and we have a few agents now, and we're experimenting, and we're going to have a million different routes through our thousands of agents in a few years. How do we begin to manage this? And so, we're making the play for managing the agentic workflow. So there's people, these things are scattered. No one knows who owns them or who's using them. Identity and data access policies aren't enforced or uniformly across agents, tools, and platforms in the enterprise. We have difficulty enforcing least privileged things that we've come to sort of think of as motherhood and apple pie in the identity world recently. These things are sort of an afterthought right now as everybody sort of lunges forward, super fast, trying to achieve sort of like brand new insights and gains and, all kinds of efficiencies. They lack human oversight and proper delegation. Explosions of internal tools and external MCP servers creates confusion, and we risk a lot of unintended data exposure. Okay, We want to move from governing data to putting well-governed data into action. So we want to give agents identity. Agents are materialized in the graph. Ownership is maintained through adjacent graph objects. And at the end of the day, we have now a catalog of agent skills and tools. We want to manage delegated authority properly. We're using the OAuth token exchange specification for using this for delegation. Right now, in our demo that I'm going to show you, we're using Curity as a third-party IDP, but Curity supports this delegation token exchange, and you'll see how that works in a minute. Agents have no standing privilege in our world, but instead get their context from a calling human or another calling agent. We always have a full calling chain from the first user to the last agent, all the way through. And we want to have dynamic policy enforcement, agentic workflows, and the calling user context. Okay, so that was a lot. Here we go, reference architecture. This is the part that's better, I think, probably for everybody. But this is kind of where I'm getting at. So if you look here in the bottom right-hand corner, this is kind of the thing I'm describing. We have in the bottom left-hand corner a series of sort of enterprise systems like Workday, SharePoint, Salesforce. These are things that exist in every enterprise. But all of them, and if you look at, like, again, we are going back to the Foundation Capital story, but the Foundation Capital story, I think the reason it resonated with so many people is it's very true. We're looking to try to do something right now, and the data is there, but it is all sort of focused in one place, and it isn't knowledge. We believe that bringing the data from, shards of data from different systems into the IndyKite control plane through, our capture API, we can then amass different pieces of information from different systems and build an important, context for understanding the enterprise. So, and then here on the bottom right-hand side, you'll see I've got like an external reference thing. The IndyKite control plane, we don't have to actually just materialize all the data in the graph. Sometimes the data is best served being left outside the graph. It's temporal or telemetry data that maybe needs to be accessed at one point in time and not all the time. And we don't need to use it to fill up our graph with all this information. So we can reach out and call various APIs to get what information we need from places, and here I'm going to get a stock quote. It's a little example I have. So if I move up here over to the left edge, we've got a human, and then we've got an agent gateway, an orchestrator agent, and another gateway, and another retriever. So these three things are going to basically, our user is going to try to get things from them, but we're going to use the IndyKite agent gateway to sort of make sure that it's the right user in the right workflow, calling the right things. So the user, when they make a call, they're authenticated as themselves. They have their own token. So again, we're getting this through the IDP up here. The IDP has issued a standard OAuth token for our user, our human user. And then they want to, type in something in the chatbot and fill in a prompt and get some response back. So that information then flows to the IndyKite agent gateway, and the IndyKite agent gateway is like, oh, okay, cool. This is, Joe wants something. I know that the agent one, I know their token and their identity, and I'm going to take these two tokens and I'm going to give them to my IDP. And then again, in the case that, again, in our example, this is going to be Curity. And again, it's anybody that's any third-party sort of IDP that is going to be OAuth compliant and support the token exchange flow. Anyways, both these tokens go into the IDP, and it says, okay, now I'm going to grant and mint a new token where the calling human is the subject of that token, and the agent is now the actor of that token. So the actor is going to act on behalf of the calling human. So now the agent gateway's got this chain, this delegation chain baked into the token, and it's like, okay, now I know that Joe called agent one. Is this a valid workflow? So it's going to call back into the IndyKite control plane, make sure that this is a valid workflow, and it's like, if it is a valid workflow, then it's going to go and actually see if Joe is actually allowed to call that workflow. If Joe's allowed to call that workflow, It's going to be like, okay, my work here is kind of done. I'm going to let this request go through to agent 1. Agent 1 is like, okay, well, this is actually a retrieval request. I know I need to send this down to agent 2. And so this whole thing repeats again. But this time, the calling token is the new augmented token that has the subject from the original user and the actor, who is agent 1. So now agent 1 is acting on behalf of the subject. We call agent 2. Agent 2 is like, oh, okay, cool. Or I should say agent 2 gateway is like, oh, I got another request. I know I'm representing agent 2. I'm going to send this new token and my agent 2 token up to the IDP. It's going to go do the token exchange, bring them back, indicate the gateway is going to go say, oh, okay, is Joe to agent 1 to agent 2 a valid workflow that I know about? Oh, yes, it is. Okay. Is Joe actually allowed to call that workflow? Okay, perfect. I'm going to let that prompt proceed. Now that prompt's gone off to agent 2 retriever, and it's like, okay, now I'm going to do some retrieval against my MCP server. So it's going to list its queries or do an authorization call. In our case, maybe it's going to do what we call a CIQ call or a context IQ query and query the actual control plane itself for something. And it's going to do that inside the context of the token. So in that token, we have all the actors. We have agent 2, agent 1, and the original subject. So we can provide like a full context of calling. So even though Joe might have access to all kinds of things, maybe in the little slice of this transaction, Joe plus agent 2 plus agent 1 only has this much access. So we can immediately sort of, with the right information in the graph and knowing about who the calling agents are, we can scope down like what the agent is actually going to be able to do. Whew, that was a lot. Anyway, I wanted to go fast and get through that, but now I'm going to just jump into a little demo and see if I can make this actually work. So hang on. I have to go up here and minimize this. All right, one thing done. All right, and I can just squish this over here. Okay, and here we go. Okay, so here we have like, this picture represents basically what I have running on my laptop and a couple other things. But essentially, agent 1 is going to be an orchestrator agent. Agent 2 is going to be a retriever. And this is like an IndyKite little chatbot. So we built these things to show off sort of the gateway and the MCP server. So here we go. I am going to now, actually, you know what? I forgot one thing that I wanted to show you. You know what? We'll do it after. Basically, though, I have a couple of fictitious users. One is Rebecca, and she's a customer of a company called CanBank. Can everybody hear me all right? And then I have another user named Leslie. And Leslie is a customer service rep for CanBank. And then I have another user named Roy, who is also at CanBank and is a trader. And now Jessica's just got her credit card bill and realized that she was late making her payment and has received a fine. And she wants to phone CanBank and see if she can get a refund on her stuff. So she calls up CanBank and she is now talking to Leslie. And so Leslie's going to log in to the IndyKite control plane. And here you can see this is Curity. So Leslie's logging in and getting bounced out to Curity. And this is Leslie's logged in. There we go. Okay, so now Leslie logged in. What's running over here on the right-hand side of the screen is, this here is the retriever agent. And basically what's going to happen is it's going to get some instructions eventually. And here in the right-hand nav of the chatbot is basically agent communication with the gateways. So if I go, I'm gonna just see what Leslie wants to know is what policy documents pertain to refunds. So Leslie's got this request from Rebecca, who's kind of a little upset because she's a good customer of the bank, and he wants to know what documents we have. So we've got some documents in the knowledge graph that have come in from SharePoint. This data is basically ingested and tagged, and so we know a little bit about it. And what's happened here in the right-hand nav is the orchestrator agents got a hold of this, and it said, okay, here you can see I'm forwarding this request, and then the refresh token's received. The token then, we test to see whether the Leslie indicate agent 2 chain is valid, and then it sees to see if Leslie is actually allowed to call that, and sure enough, he is. I'm sorry, but an error occurred when trying to retrieve information about the policy document. That's awesome. Demos are fantastic. Let's try one more time. What's happened, though, is the request has gone through both agent gateways and has actually hit the MCP server, or we're trying to hit the MCP server. And it's doing something. Oh, look, I got a response. Yay. All right, so basically, Leslie wanted to find out information about things, and he found out that there is actually a policy document pertaining to customer refunds. So now he wants to see if that has actually been used in a past decision. So we're going to then put this in here, and Leslie's going to run this. And again, this is going to pass through both agent gateways to the second retriever agent, and the retriever agent's going to use the MCP server to retrieve a CIQ query from the Indicate control plane that's looking for past decisions that might help Leslie. Okay, and we did find a past decision. And so we can see in this decision here that Leslie, when his actually now boss, Flo Collins, who is a CSR2, which is what Leslie is right now, she has previously approved something for a customer. So Leslie feels pretty comfortable now that he can go into the credit system, give Rebecca a credit that she deserves, and then he can go and then enter that in the CRM system, and that decision then will then eventually flow down to the knowledge graph, the context graph, and form new sort of informational knowledge about what actually transpired, so that in future decisions we can factor in those things. So now Rebecca's got this problem solved. She wants to go spend some money. She feels like she should buy some NVIDIA shares. So now she's gotten handed over to Roy, and Roy works in trading stuff. And Roy is going to log in again as himself. Again, we're back out to Curity. All these things are generating OAuth 2 tokens. They all have the subject of the user. And maybe I can log in. Oh, that's not good. Let me try that again. Log in. All right, there we go. That's better. Okay, so now Roy knows that Rebecca actually has a limit on her account as to how much she can spend every day, but she really wants these NVIDIA shares because everybody does. And so Roy's going to ask. This is a little bit contrived, I know, but she's going to ask how many NVIDIA shares can Rebecca purchase for her. And so what's happening is it's going out to the MCP server is calling that query to look for a stock quote on the internet. So even though our agent doesn't have any internet access, it's getting a very specific stock quote from the IndyKite platform through that external call. So that's one call that the MCP server is making. The other call the MCP server is making is to see what Rebecca's limit actually is. And so then it's just dividing through by the share price. And I can see now that Rebecca can purchase 54 shares in NVIDIA. When I ran through this demo this morning, Rebecca could only purchase 53, so she's much better off. Anyway, this is just fairly contrived sort of examples, but one thing I wanted to show is that, even though Roy and Leslie work for the same company and have worked with the same customer, their contexts in dealing with her are different, and the MCP server respects that. So when I tried to execute something like one of the calls that Leslie did, maybe what policy documents pertain to refunds, which is a pretty benign thing, but I know that in the graph, these policy documents only apply to Leslie's department and not to Roy's department. So when I fire this prompt, I'm expecting to get sort of a negative result back, and I'm pretty sure I'm going to get one. But it is LLM land, so you never know. But fingers crossed. Yeah, sure enough. I was unable to process your request, check the audit log. But basically what happened was the MCP server found the exact same query, but called it. But this time it called it as that third token with, the subject and the to identity in it. And it's like, it's not going to serve that response. So the last thing I'm going to show you, which is what I was going to show you before, but I was rushing so fast. This is kind of the IndyKite control plane, and here's just a picture of sort of the part of the graph that we were looking at. And so one of the things that in our world, context are these decision traces, but the context is also stuff like where did this data come from? So not only do we have in the customer account node the properties, but on the property we have the provenance of this. And so this sort of fourth dimension of the data is also, in my mind, a big part of the context. So if we want to basically validate the data and make sure that it's good to work with, we have trust scores and data validity that we can then use in queries. And we can make sure that the impure or unwashed data is not part of the decision-making process. Anyway, that's me. Hopefully I wasn't over, but yeah. Thank you.
Thank you so much, Dave. Thank you, everyone. Okay, so I know we have an incredible next speaker, and while they are setting up, this is going to be real hilarious, everyone. So I'm going to actually call up my colleague Jeremy, who's not ready for this, by the way. So my colleague Jeremy, this is Jeremy. Yes, you. That's right. I want my man over here. All right, so Jeremy, we have a friend in the San Francisco Bay Area. His name is Adam Chan. Yeah. And Adam, often when energy's getting a little low, right? When energy's getting a little low, Adam likes to do this thing. Yeah, you know what I mean? He does this thing, right? He does this thing, Adam. He does this thing. Okay, so he does one-legged boom. You know what that is? One-legged, he tries to do a whole thing going down and then going up. It's so hard. It's literally so hard.
So hard.
Do you know how to do it?
I don't know how to do it.
Oh, it's perfectly fine. I honestly don't have the secret, but it's okay. Okay, so what we're going to do is we're going to pause on that because I think our friend is almost ready. Actually, he's almost ready. But okay, he's almost ready. We'll give it some time. So what I want to do for everyone who is willing and able, this is just something to get you to wake up, all right? So everyone who is willing and able, I want you to stand up. Yeah, we're going to do this together, everybody. We're going to do this together. I want you to stand up, and you're going to try and do a one-legged squat. Okay? I know, a one-legged squat. All right, we'll go down. Everyone go down, 2, 3, 4. Hold it, 2, 3, and back up. 2, 3, 4. Woo! All right, thank you, Jeremy. Awesome. All right, so that actually really hurt. You can see my age, all right, at this point, but I'm just trying to wake you all up, get creative, get your bodies moving. And I would love to introduce my incredible colleague, Jan Billion, okay, who is the co-founder and chief scientific officer of Rippletide, okay? So just a quick introduction before we go. So he is going to speak today on automatic ontologies, right? The O word, the big O word. Build the context graph for trustworthy AI agents, where he's going to argue that AI agents don't fail because the model's capabilities specifically, but actually because there's no structured context, right, to ground their decisions. And so I'm going to pass it off. Let's give Jan a big round of applause. Thanks so much, Jan.
Hi everyone, and welcome to this last talk. Thanks for the energy. That's very nice. So I'm Jan, co-founder and chief scientist of Rippletide. We are a 2-year-old company, and we are focused on bringing the right context to the agent anytime, and even more. So we are building a decision infrastructure. And before that, I was doing AI research at Imperial College in London on the limitations of reasoning models, language models, especially for the reasoning. But today, for this talk, we'll go over something else, is how to actually build such context graph. I hope that thanks to the past talks, now that you want to build such a graph, so we'll see how to do so. And to start, I'd like to make a confession, is when we started at Rippletide, onboarding the first customers was actually really, really painful. The point was, we had to build those graphs manually. So we have to build knowledge, processes, everything that was described before manually. And this is kind of a really, really big pain that we had to solve. And so as a researcher, guess what? What did we do is we brought some bright minds and we worked on it. And so we are now 18 months of R&D later and real enterprise deployments. So happy to share how to automate the creation of graphs, and especially through ontologies. So, as luck would have it, I'm the last one to talk, so I won't dig into what is a context graph. I hope you understood that before. Maybe I can just show some real example that we did on production deployments, so that you can see real examples. So here is the first one that is on a coding use case. And you can imagine this one was used as a testing agent. So every time you commit something in your repo, you want to test everything from your repo. So this is kind of small graphs. We can also have much bigger graphs. As you can imagine, as you ingest more and more data, it tends to get bigger. And maybe a third one that is smaller, that is one focused on credits. So it's for a car manufacturer. So how do you provide a credit or not based on the customer you have? So what do we have in such graphs? You have mainly 3 things. You have some knowledge. So that's, I think you know, knowledge graphs, that's kind of a fairly common thing. So that's entities. So I don't know, for example, client, vehicle, or something like that are linked through dependencies, so transitions. So that's point number 1, but it's rather classic. The second thing that changes with context graph for agents is having processes inside the graph. So why do we want to have processes? Is we don't want to let decisions to language models. Otherwise, you will have all the drawbacks of language models that you all know, hallucinations, not following some things that you ask to the model. So you want to have that processing inside the graph so that you can build the automations and the decisions directly into that. And the third thing that we have, maybe we didn't talk about it before, are guardrails. So we can put definitely guardrails into a graph directly. So why not benefit from it? Since if you put guardrails into a graph, you can just forbid some part of the graph so that you can have deterministic roles and not just putting a prompt and then hoping that it will be followed by language models. So basically, we have those 3 elements into our context graphs. So some knowledge, and some guardrails directly living inside this. All right. maybe I have a question for you for the next part is, how many of you intended or already considered using a context graph project? Just to raise hands. Okay, I'd say 60%, something like that. Okay. And so second question is, how many actually built one and that is running in production? Okay, I'd say maybe 15%. So we'll make the talk at least for the diff of the lowered hands that wanted to do so, but did not finish that. So we're going to see how we can automate this thing. Maybe just to introduce how to build such graphs, you have three main challenges to tackle when creating graph, and that are long-standing challenges for building graphs. The first one is the initial setup. It's always painful to do that manually, and there are some challenges that are tough to solve. Let me give you an example. If you connect to multiple data sources, let's say an ERP, something like that, you have a column that is called revenue, you take a CRM with a column revenue, are we talking about the same revenue? Yeah. So that's something you have to explicit, and AI has a lot of difficulties to do that for you. Second challenge is once you build the graph, you need to represent this graph. And as we've seen before, graphs can be very, very large. And so you have some difficulties to represent those graphs. Maybe I can show you some ways to do that. So this is kind of a large graph. If you zoom a bit, you can have those clusters. And so inside those clusters, you can have all those data. So imagine all the transitions and all the nodes every time you add a new data into that. You can have very, very large things. So I'm going to show you some iterations that we did on how to represent such a graph. As you can see, this is non-usable in production, right? So I can show you all the iterations. All right, sorry for the quality of the videos, but you can have graphs that are in 3D. Actually, there are multiple dimensions. Or even when you add some new data to the sources, it tends to be very, very difficult to represent those graphs. So that are two challenges you have to keep in mind. And maybe the third one is regarding graphs updates. So every time you put a new data into your graph, you want to preserve the coherence. You don't want to break everything. So that's, let's say, the three main challenges that you want to address. And there is a fourth one, actually, is maybe you have it in mind, is once you have this graph, how to use it, for example, for an agent. I guess many of you are building agents. And the common way to do that is through RAG, graph RAG, so many types of retrieval pipelines that always tend to be bottleneck at scale. You can understand if I take the coding example, does RAG work well for code, for example? The answer is no, and so cursor and whatever, they did other methods, such as graphing and on other things. So at scale, we always see that those graph RAG things are bottlenecks. I think in one of the previous talk, there was a metric regarding graph RAG, I think it was 81%, something like that. So do you want to have only 4 times out of 5 the right context for your agents, or you risk hallucinations anytime you don't have those things? So graph RAG tends to be very limited. And so on how we developed and how to create those graphs, we try to build something else so that we don't need the graph RAG or whatever pipelines like this. And so I'm going to introduce something that we developed that are graph-based ontologies. So we want to have both a graph structure that you can have and also some ontologies. So maybe you've heard about ontology. So what is an ontology? Is just giving some meaning about some data. For example, if I come back to my example here, you have some products. This is kind of a marketplace. This was a retail customer. You have these products, so you have some attributes for those products. And so you want every product to have those attributes. And so those ontologies that can be also represented through clusters like this. You can imagine that every node actually has a lot of references into the graph. And so using those ontologies, actually the data and the processes are the same area into the graph, and so you don't need anymore a RAG pipeline to feed your agents. And the key point to keep in mind is what worked before when we talk about graphs, things like that for chatbots, does not work anymore for agents, because now you have multi-steps into your agents. So if you take something that works, I don't know, 95% of the time, so you have 5% of the time the wrong context. If you have 10 steps that are classic workflows, you'll have a kind of a 40% error rate. So that's too high. So you have to change things and how to build those graphs. Something that we understood since the very beginning is when you build such a graph, you have two methods to evaluate actually how's the graph. I don't know, the customer is asking, is it working? Is it improving my agents? And it's kind of difficult to answer that question. So you have two ways to do that. Either you want to evaluate the coherence of your graph. So for example, if I had a new data, does it break something? What is the coverage of my graph? But if you want to put agents on top of that, for you, the key point is my agent working in a way? And so that is kind of a key building principle, being able to evaluate your agent. And I can show you some example on how you can do that. So as you have some processes into your graph, what you can do is just run the agent and see how it performs on many, many tests. So every time you add a new entity, something new into your graph, you want to test your agent again and to see if it actually improves something, if you have some regressions into your graph. And so along the way, you always evaluate what you're doing along as you keep new data. So if we add this small thing, when we add new data, every time there is a new point, you want to run some tests on the agent in the background to know if the agent is actually improving or not in the end, because what you want is just an agent that is working in the end. Another thing to keep in mind, and I know it's a bit long, you're hungry, so we'll make it quick, is how to manage graph updates. So when you have a new data, how to make sure you have three things to be careful about is, one, you don't want to have incoherent data. You don't want to have contradictory data. So contradictory, that means, for example, you have a documentation that is for the credit, for example, credit agent that I had here. You have a document that says the credit is 4.5%, and you add a new documentation that says 6%. Which one to keep in mind? And if you just provide this context to a language model, it will choose one or the other depending on the times. So what you want to do is actually to explicit those inconsistencies so that you deal with those inconsistencies during the build time of your graph. And so you don't let all those computations during the inference with the risk of having production issues when it's running. So keep in mind that you want to build one time, validate, evaluate that the graph is strong enough, is working, and is improving the agent. And after that, you want determinism, you want predictability for your graph. And so the key message I think that you can keep in mind is there is a big momentum actually regarding context graphs and things like that. And thanks to the Neo4j team for having been worked on that for many years for now. But now we can have the key benefits of context graphs. So key benefits that you know is if you bring the right context to the agent, you have more predictable agents. If you have a graph, everything is explainable. And since you have processes now into your graph, you have end-to-end explainability. That is something key. And at the end, you have predictable things because you have the right context at some time. So you have all the benefits of the graphs, and now you don't have the drawbacks of initial setup or maintenance of the graph, things like that, thanks to new tools. So we can leverage language models for building the graph, but not for the inference, so that you will have stable things in production. So feel free if you have any questions. I can share maybe if it's interesting for you. You can start. We have some things that are open source. If you want to try, for example, an MCP on context graph, feel free directly on docs.tripletie.com. You can directly evaluate your agent at first, so just connect your agent. We have, for example, CLI that are running. Then you can put directly a context graph. So with an MCP, it's really easy to connect. It's a few steps. And in the end, if you want, you can go even into a stronger position with the decision runtime. So you want to have deterministic decisions once it's running. So happy to dig into everything. If you have questions, give it a try if you want. And let's go for the panel. I think I have a QR code if you want to scan everything, if you want to reach out, or if you want to find the documentation. Thank you very much.
Thank you so much. Thank you, Jan. Another round of applause for Jan. Thank you so much, Jan. Woo! Okay, everyone. So as we get set up for our panel, I want you all to do, because guess what? All right, since we're here, you might as well make some connections, right? You might as well make some connections. So what I want you all to do is to add another connection or add another relationship to your graph. And what I want you to do, yeah, pun. What I want you to do is to turn to your colleague, okay? Turn to your colleague, someone you don't know, all right? I know a lot of you came in with people. Turn to someone you don't know. And I want you to ask this question. So it's a two-parter. So if you were going to build a context graph in production, I know I saw a number of people who are actually doing that right now. What has been a challenge that you faced in that process? And then, from what you've gathered from the talks today, think about possibilities, think about ontologies as well, right? What you've gathered today, what are some possible solutions to those challenges that you've been facing? And then part two of that question is make sure that you actually get their LinkedIn, okay? So you have 5 minutes. Make sure you make those connections, and we'll get started with the panel in 5. All right, thanks so much. All right, everybody, get those LinkedIns out. Get those LinkedIns out. We're about to get started with the panel. Yes. Brutal.
I sat down for I thought we were gonna do like push-ups or jumping jacks.
Yeah. Like, no, we're doing.
In place. If you fall, you just go on your
Just go on it, and you're fine. Yeah, that's right. I love it. All right, everybody, we are going to get started. Woo, woo, woo! If I can have all the speakers come up and join us. All right, everyone, we're going to get started right now. Make sure you have everybody's LinkedIn. About to get started in the panel. Awesome. Okay, everyone, thank you so much for staying for this incredible conversation. We are now going to get started with our, okay? So we have a panel of esteemed experts. Thank you so much, everyone, for joining me. Wonderful speakers. And everyone, we have a special guest as well. So hello. This is Emil. He is the CEO and founder of... Thank you for joining us today, Emil. Let's give him a round of applause. Woo! Excellent. Okay, so today this is such a special panel. I'm so glad everyone's here and is going to be able to capture this. So the first question that I have for you now, right? I think that we have to get some common vocabulary going before we dive in, right? So just to level set for that common vocabulary, I'd love to hear from everyone on the panel and Emil as well. We are going to start with, can you articulate for us? And can you help us understand what the difference is, and specifically what the difference is between a context graph and a knowledge graph? What's the difference there?
Wet water.
There we go. Say more.
I mean, in my opinion, it is. I know that we're still trying to define an industry, but I'm going to say it is a knowledge.
Yeah, I mean, terminology definitions forever, and of course, it's valuable to have some understanding of terminologies that we, on some reason, about the same kind of things, right? To me, it's simple. A knowledge graph is a superset of a context graph. Graph is you take your data in your domain, press it in a graphy form, and Will showed kind of the pole plus or whatever, people, organization, location, event, and objects. That's one expression of a knowledge graph. And then in that case, you have the context graph, which is kind of the decisions that are then added on top of it. You want to connect the decision traces to the your knowledge graph, right? So that's kind of at the high level how I look at it.
Yeah, and I think just maybe to reiterate this idea of overloaded terminology. I mean, the word context is so overloaded, right? We use it to talk about a specific text that we inject into the prompt, right? We call this like the context window. We as relationships, the metadata, like all of these things like are very overloaded. And this is, I talked about the near agent library in my talk, and this is one of the choosing what are the abstractions that we want to expose, and you read the literature on this, and it's like semantic memory, episodic memory, procedural memory, user probably like what's the difference, right? And so I think trying to go with short-term, long-term reasoning, and I think that cap out of like what folks are trying to address. So anyway, like I just reiterating, like yes, this terminology, people mean lots of different things when they say context, graphs, knowledge, all of these things mean different things to different people. And so yeah, something definitely to be aware of when you're building tooling as well to think of.
Yeah, I think on my side, I'd like to describe context graphs sum of two different graphs, both knowledge graphs and the graphs of action and procedures. So you just put those two graphs together, and in the end, you have the context graph to guide the decisions of the agents.
So I'd say when that foundation capital paper came out, that it actually caused quite a bit of, our CEO was like sent it out to all of us like right away, and we were all like, it spurred debate, and so I think the water that really resonated with, but I think for me, it's more like the knowledge graph is a superset of the context graph is really more like any sort of extra dimensionality rather than like, that simple triple. And that extra dimensionality could be the decision trace, or it could be, data provenance about some of the properties that are involved there. I don't think there's like this like rigid box it fits into, but I think the nuance is just the extra dimensionality.
See, and that's why I really appreciate making sure that we have that common language, right? That common conversation. Because so many people do define it in so many different ways. And in many ways, it is a water is wet. And for those of us who've been in the knowledge graph and context graph space for so long, like this is not a new concept, right? So trying to make sure at least when newer people are coming into the field and coming into the conversation that we're at least having the same kind of conversation at the same time. So I also want to then move forward with the understanding like there's so much excitement that's happening right now, right around context graph. And some might argue that this concept has been around for decades, right? And then, and some might call that as knowledge management, just like Jessica had mentioned as well. But I want to take a step back. I want to take a step back and thinking about making sure that the audience can understand why is this concept so pertinent right now? And I don't mean just right now this month, right, or the last few months. I mean within this larger history of agentic development. Why now for context graphs?
Yeah, I think so. Everyone sees the benefits of the context graph, and it's a concept that has been for a decade or more. And so why right now it has huge momentum is thanks to the latest LLM, Gen AI advances, you don't have anymore the drawbacks that you had before on initial setup, on maintenance, updates, things like that. You can automate a lot of things regarding that, so you are erasing a lot of drawbacks that you had before. So you keep the benefits and you don't have the drawbacks that you had before. So I think it evolved. It's kind of the past to build manually those graphs and so on. So now we enter into a new era, a new generation on how to do that. And so happy to do that together.
Yeah, I agree with that. I think it's funny, right? remember last year was supposed to be the year of agents, right? And no, specifically agents in production, right? That was what last year. And then I think Andrej Karpathy gave a talk at YC saying, actually, it's more like the decade of agents in production, right? And I think he was very right in that. I don't think we saw certainly agents go into production last year, but by and large, it's very, very early still. And I think what Context Graph, what that blog post did, and I think in a really eloquent way, was that it established or popularized this terminology for something that I think is a really central part to make sure that agents actually work in the real world. I think there's, broadly speaking, 4 sources, 4 buckets that agents require to be useful in production. They need access to the system of records, so that is the present state of your organization, right? This is your CRM systems or what marketing systems, all that kind of stuff, right? They need access to your data platform. So this is, I always think of this as system of record for history. So this is your Snowflake or your Databricks, your data warehouse, that kind of stuff. They need access to the agentic memory. What is the conversational state, the session state for your agents? And then now we have a term for this other piece, the decision traces, the institutional knowledge encoded in some way as the 4th piece. And I think what's emerged now is that you give your agents access to those 4 pieces, right? That is sufficient data, sufficient knowledge for them to actually work in reality in production. So I think if many of us have written similar things to what the Foundation Capital guys did, like 3 years ago, 5 years ago, 7 years ago. I feel like I've been saying the same damn things for 20 years now, right? In so many ways, right? But I think it's a little bit how they wrote it, but also like this moment in time and this really central piece of information that is required as part of the underlying substrate for making agents work in reality. So I think that's probably why it grabbed like all this attention.
Okay, I'm going to draw it out a little bit, sort of a wider lens. Is also workflows. I think that's just a common element that most people are dealing with is workflows, and they're trying to automate workflows. And so this is a logical step towards doing so reliably. And I think that crosses. The other thing is it crosses industries, and it crosses environments. So it's something that's easily relatable.
Do I have to pay you later, or? I feel like that was set up for us. I couldn't agree more. To me, though, it was the timing was right? Like it was like that paper dropped at like the exact moment. Like Emil said, it's like it was supposed to be the year of the agent, but everyone's you got so far, and then that paper just made so much sense, and so it hit the nail on the head. I think. New word and everything.
There was a study a few months ago, I think from MIT or something, that said that 95% of AI projects fail to deliver value, right? And I think the reason for that is the data problem, right? Like in this case, agents don't have access to the right data, and so those projects are failing. And now folks are going back and sort of re-architecting this and realizing, okay, well, if data is the issue, what do we do at the data layer to provide the most relevant data, most relevant context for our agent? And so I think a lot of people are struggling with this problem of how do I get the right data to my agent as they're introducing agents to help with workflows and help augment human knowledge work, right? Essentially, we want these agents to help employees be more productive is sort of how I think it's going. And I think what folks are realizing is when they're trying to help the agent implement policies and make decisions, they're like, well, we don't even document and have proper data on how the humans are making these decisions in an organization and doing that. And that was a big realization of oh yeah, we have all of these policies and data in different systems that maybe as an analyst, your job is to go out and fetch those, or you build systems that interact with those. So I think that really resonated, and folks are going back on board and realizing, oh, I need to build my context graph on data from folks' heads that Jessica was talking about to represent that before I can expect an agent to give me a valid recommendation to understand how we do things now. So I think that's a big part of the timing as well.
And so moving away a bit moving away from why context graphs really make a lot of sense for the now, right? I'd love to know, based on your analysis of the conversations that are being had around context graphs, what are you seeing is actually missing from this conversation?
Knowledge management.
Say more.
It's like an elephant in the room. I mean, no, it's something we want to automate so badly, and we've never really taken responsibility for organizing our actual knowledge, yet we cry when humans are automated. Like when the human process is automated, I don't really have a solution for that necessarily, because it needs to be a relationship between humans and machines, but it also needs to be an investment from organizations. It just needs to be. We've avoided it. It's something that organizations have not invested in up until now, and I think we're at sort of a crux where we aren't going to really have an option. I just bring down the party. Sorry.
No.
Okay.
Not at all. Not at all.
I think that's totally fair. I mean, I spend a lot of time in organizations, and I'm sure everybody in this room does too, and nobody ever wants to do that work. People don't keep track of things. At the end of the day, it's a human problem will limit how far this can go. And until the hard miles, I think, are walked, I think Jessica's kind of bang on.
Yeah, and a part of the reason why I ask a question like that is because I think it's so important when we're having engineering teams, right, that are actually building out context graphs. We want to make sure that we are having a comprehensive understanding of the problem, right? The comprehensive understanding of how do we build out and implement knowledge graphs into our systems, and in ways that speak to, or at least involve different frameworks, right? Ontologies, just like you mentioned, different frameworks that will help this process become more effective in the long term. So that's just a little bit of the reason why I want to make sure that we're also hitting upon what's missing in the larger conversation around context graphs right now, right? Even with all the excitement and the hype around it. What can we be laser focused on in making sure that we're solving this comprehensively? So yeah, perfect. Okay, so also, because of this larger reinvigoration, and don't worry everyone, we're going to have time for questions from the audience too, so get those questions stirring up. But because of this larger reinvigoration, I'll say, around the concept behind knowledge graphs and the new focus on context graphs specifically within agentic development, I'm seeing a lot of the conversation be a little high level, right? So I want to dive into the I want to dive into the weeds. So what does implementation of knowledge graphs, look at that, of context graphs look like within this space? And I know a lot of us have companies and have engineers who are actually building out context graphs right now. So what does implementation look like, and what should it look like? What advice would you give to engineering teams who are trying to build out context graphs right now?
Yeah, there's so many pieces to this, right? And I talked about in my talk. I talked about the Neo4j agent memory package that we built to try to enable recording things like your reasoning traces and these sorts of things. So I think that in my talk are most important around getting the entity extraction right, thinking about the data model that you're using for entity extraction to match your domain. Like this, I think is really key, is really important. But then it's a lot of things like, how do you represent the canonical representation of some concept, these sorts of things to understand and make sure that your data quality in the graph is sort of where it needs to be. This idea of an entity-resolved knowledge graph, I think, is kind of the term for this. If you search online for what that is, you'll see some of the techniques for creating an entity resolved knowledge graph. And like that problem doesn't go away with context graph. The challenge doesn't go away with using an LLM for any extraction. Like you still have to reason about this and proper data modeling and things like this with your context graph.
I think the most phenomenal, if you guys have a chance to look in the GitHub repo of the PKO project, the Cephreal project, you'll see that there's a very cool package for knowledge elicitation. I know I hit on that during my talk, but it's a framework, and it exists as like a plugin for the browser for human users to be able to enter context about workflows in sort of a form. I am going to say that that's something that I've seen to be very productive and successful, is to involve humans, but also human verification. And to also note that there can be multiple workflows, especially if you have situations where a company has a lot of acquisitions. And so it may not be linear. I think that's really important, is to be kind of heads up that it's a little bit like a fingerprint.
Yeah, from a very practical use cases, we've seen a lot of people using MCPs to leverage context graph. So for example, something that works well we've seen is plugging an MCP into your IDE for coding, so that you can have a personal memory that stores how you code, what are the practices of your company, and so the MCP is both learning, so listening, and then serving the right context so that you have no regressions and it's coding how you like to code. So that's very practical implementation through MCPs. Maybe it will evolve, but today it's very, very practical and people use that.
So for me, I'd say, going back to what Will said, it's like getting the right data in the right place, in the right format, right at the right time. And but is it good data? A lot of our data is uncleansed, unwashed, and so being able to identify the things that can be used and segregating them from the things that can't be used is critical, I think, to success.
Yeah, if I think about like what are the big things that have changed over the last couple of years after having spent a while focusing on how to build systems with graphs, I think there's maybe two things that are emerging, right, in the last couple of years, right? One is we did a ton more unstructured data than we did 3-4 years ago, pre the ChatGPT moment, right? Because LLMs give us an ability to operate on unstructured data, right? So that's kind of one. And then the other one is, more often than not, do our kind of execution layer, the agents, right, span multiple systems. Whereas 5 years ago, it was more common that an application sat on top, but it's like one system, right? And both of those, I think, just from a very practical perspective, that was the framing, like what's kind of the practical thing. One you mentioned, Will, which is because unstructured data is much more prevalent right now, entity resolution becomes much more important, right? So how do I go from, let's just think about text for a moment, like lots and lots of text, to extract that into real entities. This is a node called ML, right? And then there's like an ML A-frame, there's an ML G A-frame, there's William Gates and Bill Gates, like named entity recognition. There's different terms for that, but like how do you go from all that into like this is a node, right? So that's a really fundamental capability that existed 10 years ago. You mentioned entity resolved knowledge graphs, like sensing, Jeff Jonas, I talked to him about this 15 years ago, 20 years ago. So it's been around, but it's way more important today compared to 2 years ago.
And I just published an article about forming it into RDF.
There you go.
I did with sensing.
Okay,
the
with
project for
Jeff's
sensing.
team. Yeah,
And
yeah.
we published the report that makes it so that you can transform into ontology.
So I think that's one thing, and then the second thing is what you just mentioned, and you even said the O word, or maybe you said the other word, right? Which is, so ontology has been this word that I personally try to avoid for 2 decades, right? Because it was it just brought in this notion of complexity. And one of the problems the graph world has always been plagued with is that we love our fancy terminology, right? And I personally hate that. And like, I think much of the success that Neo4j has enjoyed has been thanks to our ability to simplify things and just make it just, it's not that hard. The concepts aren't that hard. You have like rings, and then you have arrows in between the rings. And they have some stuff, like, come on, it's not that hard, right? And so I avoided the word ontology. Ontology is really coming back right now, and I think it's thanks to AI and LLMs, and honestly, thanks to Palantir. I think those are the two drivers of that, actually, right? But if I then think about kind of shift, where it used to be like singular systems, and now our agents span multiple systems. Okay, if you just have one application with one database backend, you have your ontology. It's like expressed in code. It's expressed in the schema of that database, right? Now, more often than not, we span multiple systems. So that and making it, constructing it such that you can compute just becomes even more important, or like way more important than it was before. So those are the two kind of practical skill sets, like entity resolution and then ontologies, that I think are more important now than it used to be.
Wee, I love this. Okay, so then picture this, right? We're an engineering team. We have developed a context graph. It's up and it's running. So I'm wondering, what is each of your visions for what the future of this space looks like, right? What does the future of context graph look like? If you can not even predict, but what would be your ideal future of the conversation that's happening around context graphs?
I think the ideal state is that it goes away. That's about it. Everyone just knows that in order to make our AI systems, whatever we make, or whatever, make them work in reality, you need to somehow make the institutional knowledge and all the real world decisions part of it. It's not even a discussion, that's just what it is. It's like, do you do unit tests for your code? Well, like, no one talks about it anymore. It's just part of the hygiene of writing AI capable software. So that'd be my take.
Yeah. You have something at the tip of your tongue, Will.
Yeah, I mean, I think Immel's onto something there, right? That like if we, I spend a lot of time thinking about the interplay between agent memory, knowledge graph. Now we're talking about context graphs, and specifically in the AI space, right? With AI agent memory is like such an important piece, right? It's the essentially like the knowledge, the background, the library, if you will. Sure, I like that. That's a good one. And so I think, yeah, like kind of reiterating Immel's point, like ideally that everyone is just using a context graph as part of the AI agent memory. It's part of the library that they're building. Yeah, I like that.
So I want to make sure that, number one, again, we have time for questions, so please feel free to, I would say, either put your hand up if you do have a question for a member of the panel, and my colleague Yolande will come around with a mic for you, and I'll just ask one last question to the panel, just to see where people can learn more, right? So I'm wondering, from all the research that each of you has done in this field, the years and years of research, right? What is either one piece of research that you think was pivotal to your understanding of context graphs? Or I would also ask then, what's a place that people can go to learn more from your perspective?
For me, it was building one, like just getting hands-on, like okay, everyone's talking about this. I have to see like what is this really when I go to actually like build one. So that demo that I showed, that context graph demo, that was kind of my my first like hands-on keyboard experimenting, and that was like a really good learning experience for me. And that's kind of I think true for me. And maybe that's the talk about learning modes and that sort of thing. Like after I read a paper, it's like okay, I want to like build that. How does that actually work, right? And so I guess what I would say that like a resource to learn more would be go to the demo app that I showed. It's like contextgraph.demo.vercel.app or something like that. And there's a blog post. The code. I tried to put in a lot of like explanatory information about how it works. So if you're similar hands-on type, that's a good approach. Like clone the repo. Get it running, modify it for, I don't know, maybe a manufacturing context graph, right, instead of financial services. Maybe see what's involved in that.
Yeah, I totally agree. Just try. The barrier is now lower to build such context graph. So trying is the best way. And so something that is pivotal, I think, is being able to evaluate the impact of your context graph on your agent. So just pick an idea where you can evaluate the results. It can be code, for example. You can just run the code and see if it works. Take something that you know, maybe, in your life or in the work, and build a context graph, evaluate the results, modify the context graph, and see the results on the outcomes of your agent. That, I think, the best way. And so there's a lot of documentation now online to build such context graph easily. And the demos, POCs are not very quick. Production is, there is a big gap, but at least to try and understand, it's easy now.
For me, it was just like Will. I was like, same thing, just build it and see where I fall down until I get it right. And so that was it. I think for me, though, my next thing is what I really want to do is dive into the PKO website and see if I can sort of become more academic about this and less, not that I don't want to draw circles and sticks, because I like that part of it. It's great for explaining, works well in the enterprise, everybody understands it. But having a little bit more academic understanding of it is, I think, probably worthwhile.
You're saying less vibes.
Yeah.
Less vibes, baby.
I'm a nerd, and I believe in research and building on prior art, and so there's a wealth of knowledge out there. I will say in the GLAM space, libraries and archives, like this is not new hat. There are networked, there's actually networked procedural ontology systems that exist right now that connect worldwide libraries and archives, private, and so it's been done. So I do believe in also studying the work of others and really being able to derive and point and cite to other sources rather than reinventing the wheel. Vibes are okay, but if you're serious about building, I think it's important.
For me, honestly, it's Will's blog posts.
Yeah.
Like, they're really freaking awesome. And like the blog post, like the Lenny blog post, and so there's a couple of amazing blog posts by this guy about context graphs. That's all you need. That's all I needed.
Oh, that's right.
I'll second that.
If you all saw me come in, side note, and Will knows this, I had a stack of research that they had done based on, so that we can have an intellectual conversation about context graphs. And so, yes, I also would say that those blog posts that everyone has written, right, blog posts, other research as well, have been pivotal to better understanding both the world, but also like the potential of context graphs, and not just the term itself, but the concept behind it. So, okay, so we're going to open this up to those who have questions. See a hand, so we'll go to him first.
This question's for Will. I don't know if this was supposed to go to me, but I've got it now. This is for Will. The whole agentic memory, is there a practical way to like drop this in almost like as a plug-in to an OpenClaw and have it just like learn context? Is anyone doing that yet? It seems like an obvious fit.
You're specifically asking about the agent memory package that
Yeah. Like, could you have an OpenClaw agent essentially build out its own context graph just as you use it, such that it would perform better in a way that would be like plug and play?
I haven't, but I have a spare laptop in my room, and we'll play around this evening and see where it goes. It's a great idea. That's right. Search for the Balmer peak area.
Hi. Well, thanks for taking your time to enlighten us on all these topics. Really appreciate that. I lead finance systems for my team, so basically helping finance go from sales wants to do something, engineering wants to do something. What does that all look like on a P&L or balance sheet or cash flow statement? So in that sense, finance runs the business really and makes all these decisions from a strategic perspective. So when you talk about tacit knowledge, like finance is really ripe for that in a big way. So I'm trying to think, how do I transform my team's way of getting to the decisions they need, and also just going from data to insight at speed. And the LLMs coming through was a big part of, hey, how can we use this and plug it into our process in a way that still helps us maintain accuracy and flexibility in ways we do. So I read Seth Early's book on ontology, and that really blew my mind, which is why I'm here. So I'm curious to know, like, especially for Jessica and Jan, when you step into spaces where businesses are trying to maximize the use of AI, one, how do you go about, we have nothing, and two, we have a context graph, and we're deploying LLMs, and we're really reaping the benefits of AI? And how do I bridge you've got your process, which you've been working over 25 years, you're bringing a high-level automation. How do I bridge the two? Lots of questions in there, but I'll just let you take it whichever way you want.
So the question is, how do you explicit the processes?
Let's say I have very little documentation from a process perspective, from a taxonomy perspective, from an ontology perspective. How do I get going on this journey? You have a perspective, she has a perspective, and what do you tend to see with your customers if you step into these space?
All right, you want to answer? Yeah. I think in a lot of cases, as you mentioned, the processes or whatever are not explicit. So what you want is the pipelines that create the graph to understand, as you have explainability into the graph, what led to the outcome of the agent. So it all brings back to evaluation. If you are able to evaluate, to say, I don't know, you have a customer support agent, you are able to evaluate, is the ticket solved, the customer happy? You'll be able to go back to the process that happened to do that. And then you can phrase, become deterministic, and in the end, it's a workflow. So you learn the processes along the way through evaluation. So that's why I suggest to all, if you just pick an evaluation framework that you can have, and it will learn the trajectories to do so.
I teach something and have a framework called the ontology pipeline that methodically moves from a controlled vocabulary to a taxonomy to a thesaurus to an ontology to a knowledge graph. It's iterative. And so again, I'm going to tell you that it can't be automated, because if you don't have the words and the language and you don't even know what you're trying to capture, it has to start somewhere. So I've worked with financial service companies. It's not easy, but there's different vocabularies. People have different ways of describing things across an industry. So again, while we want AI to automate things, if we don't have the foundations, it's not going to be 100% reliable. No offense, but like then when you get to evals, you don't know what's missing necessarily, because you don't even have an idea or capture of your data.
The point is, since we are using graphs, you know that what you don't know, you can know that the data is missing because you don't have the causal link to do so. So if you are able to evaluate, and that's a key point, that's why I mentioned if you have some verticals, there are now some horizontal components to do that. If you are able to evaluate, you can always go back if you're using a graph. If you're using RAG or something like that, you won't be. And that's why also I mentioned, try to use some maybe verticals at the very beginning, where it's not necessarily language, it doesn't have to be words, it can be code, for example, so that you can just run code and understand what is missing, for example, or what didn't work. So you have a lot of type of data. It can be tabular data, code, it can be words, but let's try everything and evaluate the results. You'll be able to come back to what's missing.
Yeah, so we have something in the semantic world, in the knowledge management world, called competency questions that come from ontologies, and it's what you create. It's similar to evals in that you create questions that are what you want, what kind of answers do you need from your data? And so ultimately what you're doing is you're creating that framework that helps you structure and determine what might be missing. So I think similar to evaluation frameworks, but I do think that that needs to be led by humans. I hope that answers it. Yeah, good, okay.
Hello. Hi, thanks. Wonderful panel. My name is Maria, founder of Nova. We're using unstructured data from like Jira and GitHub to find the R&D projects. And Neo4j have been using it since like 10 years ago in my thesis. And I'm glad to see that it's trendy again and that there is a new take and the use for AI basically world. I'm wondering if we are seeing that context graph is a new take on a knowledge base where you also have decision trees or decision trees. What are other ways you see to keep the graphs trendy? And then what are other things you expect to see in the graph over the years as we go and use agents in other worlds and domains? Because I think decision traces is just like one type of knowledge we can see. Do you see other ways to benefit from this? Thank you.
I mean, I see a million different. I mean, like, I do feel like the context graph framing was narrow because I do think it expands out to workflows, but it doesn't necessarily capture workflows, right? The thesis of context graphs, but in fact, if we start talking about all these different types of graphs that can exist, you're again proposing that knowledge exists in isolation, right? So we've gone down this road before, so you could have like an attribute graph. Does that make sense? Like for an e-commerce situation? I think that we start getting into dicey situations in sort of fractioning or bifurcating our environments, but maybe that's what's needed. Maybe it is, creating more of a networked graph. Maybe that's what will emerge, is a networked graph type architecture, which is not bad. That's my answer.
Yeah, it's a great question, and I think it'll be very hard to find something that is going to emerge over the next 10 years that someone hasn't done over the preceding 10 years, right? Like, you look at the context graph, and it's like, this is so great, it's new stuff, except in the Neo4j kind of user community, there's a ton of people who've done similar things for a long time, right? But it certainly reached critical mass over the last kind of 3 to 6 to 9 months, and then it emerged and it got a name and became very popular, right? And so I think everything that we're going to see over the next 10 to 15 years will be similar to that, right? Which is, okay, now there's enough kind of focus on it, right? That it emerges out, gets a name, becomes in vogue, more people start doing it, but there's always then going to be people like, I did that 10 years ago, that kind of thing, right? And they're going to be right about that. So I don't think there's like a completely net new novel thing, but certainly there's going to be more trends and more kind of terminology around it. So that's probably how I see it unfolding, would be my guess. And thanks for being a user for 10 years, by the way. I love that.
I also used Neo4j for my master's thesis as well.
Thank you for that, Will. I appreciate that.
That was my intro, essentially, to Neo4j. One thing that I wonder about, your question was sort of pointing out, like, hey, there's this renewed interest in graphs because of AI, and Emil was talking earlier about like Neo4j's success largely lies in its ability to simplify and make graphs accessible for everyone. What I wonder now is, like, does this renewed interest in AI and AI tooling, does that leave opportunity to introduce some of that complexity, right? So you talked about like ontologies as being a source of this complexity and the hesitation of sort of dive into that at Neo4j. I wonder if in this renewed interest, are we going to see more complexity added?
I have so many thoughts on this. Well, I mean, Martin Fowler had a great treatment 20 years ago, 30 years ago, around essential complexity versus accidental complexity, right? And essential complexity is, okay, it has to be there. Why? Because whatever we're trying to do is intrinsically really complex, right? I think that is, when you say, will AI introduce more complexity or drag more complexity out of the graph world, I think some of that will happen. The essential complexity. What I've always had a problem with is the accidental complexity. When we take fundamentally simple concept, sound so fancy and so sophisticated and so hard. That, I think, is raising the bar unnecessarily, right? Hope we're not going to see a lot of that, like that accidental complexity. But I think ontology is a great example, right? Like, again, I've been striking down on that word for, many years. Like, why? It's a schema, come on, make it too sophisticated. Now I'm a huge fan, I'm using the word all the time. We're gonna build in way more ontology capability into the product going forward. It's a key area of focus for me right now in 2026, right? Because the world has changed, right? So hopefully that's essential complexity and we're not inflicting accidental complexity onto the world. So that's like how I look at that.
Oh my God. Yeah. Let's see if it works. Okay, to the panel, in the context of context graphs, how would you define reasoning? And how would you compare it with purported reasoning in LLMs?
I can go first and say that I cannot define reasoning. Whenever I've tried to define reasoning, I've fallen short.
But in the context of your products, let's say.
Yeah, I mean, you mentioned RDF before, right? This used to be like one of the things that the RDF community talked a lot about, like there's reasoning included in RDF. And usually, like whenever you kind of try to pin it down, what do you mean with reasoning?
Right.
It was always some version of hierarchical relationships when you say that. Whatever, this is an apple, like some subclass of apple, and apple is a fruit, so then transitively, this thing is a fruit, right? So that was the reasoning. Like, that's a query. Come on, you don't need to call that reasoning, right? So I think what reasoning is very hard to uncover. I think very mechanically, practically comes down to getting answers out of your data. When you say in the context of our product, I think it comes down to getting answers out of your data. Typically, including queries that are more sophisticated and harder to do out of other types of databases, like a relational database. That's usually, but again, I started out by saying I can't stringently and strictly define what reasoning is.
Yeah, I think reasoning is definitely tough to define. So maybe to take a subcase, so if you take agents, what is reasoning? It's basically making decisions. So if you have multi-step things, agent needs to decide at some point. For example, should I escalate a ticket? Should I take a path or another one? So it all boils down to decisions. And the key question is, who's making the decision? Are you letting a language do the decision, if you use RAG, GraphRag, or whatever? Or are you making the decisions inside the graph, so expliciting the workflows to do that? So I would define reasoning in the case of agents as decisions rather than reasoning.
I have my opinion about reasoning. I would take it a step further. It's not so much a query. Reasoning happens by way of rules. We apply rules. And that's something actually that the original Context Graph article mentioned was rules, that we can't make decisions without rules. And so one thing that RDF, and not just RDF, but ontologies in general do is they introduce rules, which therefore introduces a certain logic, and that becomes therefore logical reasoning. And you don't, ontologies themselves don't present logical reasoning, just so you guys know. It's, and for those that do know, you usually have reasoners, and it just so happens that AI is fabulous at reasoning. They don't need reasoners, but generally knowledge graphs are an architecture. An ontology is a part of that architecture. They enable reasoning, but there's a selection, a number of reasoners that will support reasoning over your data, which is essentially respecting the rule base or the rules that you've encoded.
I think the second part of your question is really interesting, right? Because you're pointing out this idea of like purported reasoning by LLMs, right? I think there's been some research and indication that sort of goes through that reasoning and responds with its like thinking steps. That's not actually what's going on in the weights. It's just sort of like post-rationalizing that, which I think is really quite fascinating. I think if you have, though, some grounding in the context graph and the knowledge graph to accompany that like post-rationalization, you can capture that as a reasoning trace a bit better. But I do think that's fascinating research that like what the LLMs are saying that they're reasoning about are maybe not necessarily what's actually going on in the weights. It's kind of fascinating to think about.
If I tie this back to sort of my worldview, I was like with ML, I didn't think of any of the work that I was doing was like reasoning. It was actually querying, but I was trying to query in such a way that I would provide enough information for the LLM to do a reasonable set of reasoning kind of thing. It was like not so constrained, not so closed, but so that my stuff isn't so rigid and fragile. But to me, it's not reasoning that I'm doing, it's the querying.
Hi, thanks for the sharing. My question is related to the graph. So I was thinking about the context or the knowledge, why it is a graph. So if it was helping like a decision tracing, it could be a tree or it could be trial. But just the way we organize the knowledge, it just in my, so my question is like, what if it's not the graph, what else it could be, per the data structure perspective, yeah.
I can't even think of one other. Look, I think all of these data models are what's called isomorphic, right? Which means you can take data in one of them in a relational database, you can transform it into a graph, you can transform that into a document database. And so fundamentally, like you can express data in all of them. It comes down to like, what do you want to do with it, right? And I think many of the things we've seen here today is about kind of walking that data along relationships, along connections. And once you start wanting to do that, that's entirely doable with other. It's just harder. It's just more friction, right? So I think everything you can do, and it's just a matter of how much time and money you do to throw at it. But many of the things that I have the best mechanical sympathy with the graph model, right?
Yeah, I think the point is rather not how you do the data, but how you can leverage those. If you take text, for example, you can use complex things, accidental things, RAG, things like that. So the main advantage of graph is you can just walk through a graph. That's one theory on how to leverage the graph into an agent. So that's a way to leverage those data.
Sorry, I think I broke. Oh, no, I didn't. I think what's fascinating, there's more than a 10-year project that was done within the library systems. That's the linked data project. And yeah, linked data in and of itself is a graph type structure. But when you start looking at some of the nuances of, it's not a traditional graph structure. So so the linked data project was a partnership with Google, Amazon. It's still kind of going on. It's a new way of thinking of things where you basically use URIs to link records. And within the URIs, you have encoded structures. I think that's a really interesting and compact, efficient way to encode knowledge within a linked data HTTP URI structures. And linking those in between, I think it's super elegant, and you can pack a lot of information, and then you can manage the expansion and contraction of knowledge at scale. It's definitely something that's cool.
I think it's just a graph, probably. Sounds simple, but it's just how I think about this. I can't even think of another way to just sort of arbitrarily express things other than to just draw something, connect it to another thing, and if you don't like that, then erase it and try again, right? It's just, but at the end of the day, I'm just building a graph, and I can't think of then another way. How you store it, at the end of the day, who cares? But the way you sort of abstractly think about it is just, that's how I assemble knowledge in my brain. And I'm not as smart as the rest of these people, so there you go.
But yeah, we all think in graphs, right? I mean, that's what's amazing about graphs is you go to a whiteboard. We call it the whiteboard model for a reason, right? I mean, you're able to represent the way that you're thinking, and with graph databases, storing, modeling, querying your data. That's all the same data model. Like how we think. I think that's super powerful data model.
Hi, everyone. So my question is, what do you think is the potential of graph theory as a science to revolutionize the field of generative AI, right? Like, how much potential does graph theory as a science have to revolutionize the field of generative AI? For example, if we couple graph theory with neuroscience research and try to model the human brain in terms of different graphs, and try to automate those processes using large language model as a reasoning tool and so on, because a lot of the advancements or leaps, you can say, are all based on advanced graphs, right? For example, the gateway and OpenClaw and so on, all the queues and whatnot. It's more of going towards more complex graphs, right? So yeah, we'd love to hear your take on that.
Happy to go first. I think there's a very intimate connection between the graph representation of data and LLMs in particular. And I think the first wave of that we saw with GraphRag, right? The second wave of that was all the agentic memory stuff. I think the third wave is context graphs. And when we sit here a year or two from now, there's going to be wave 4 and wave 5. I think there's plenty of ways up and down the stack where that marriage is going to kind of expose itself, right? We've just seen the first 3 of them, and there's going to be plenty more. That's my view, at least.
Yeah. I think it's interesting to think, in terms of LLMs, and I think that your question is aiming towards how it will advance LLMs. Is that correct? Yeah. I think it has the opportunity to, if it's structured correctly. I think that we need also the reminder that most of these foundational commercial models, those companies are also very human. They're software companies that also have and deal with a lot of the same issues that we all deal with in our own technical spaces. I'm sort of reminded of that often. But in terms of advancing, if we look at sort of the structure of the most frequent and biggest or highest volume of training data and the structure of that data, Wikidata is one of them, Google Patents is another one. Those actually happen to all be ontology graph systems. So when we actually look at the training data that goes in and that has the biggest influence on the success of a lot of these models, I think there's more of a focus in that area. And I think the quality of the data is coming out. There's another piece of research that I've been involved with about provenance. You know, the one problem is that there's a lot of improvements that need to be made on the parametric layer in retaining provenance and citations and sources. All of that is stripped out of the data at training time. So right now we're all like on a wing and a prayer, you know, hoping for the best on the retrieval layer, right? And so I think that's where the most, the most interesting advances are starting to emerge. Hopefully. Hopefully.
Okay, everyone. So I don't have a mic. Well, thank you. Oh, you both are so kind. Thank you so much. So now I have a mic, but I know we did have two last questions. However, we are getting very, very late, and I want to make sure that if people do have questions, so what we'll do is a couple of us might be able to stay after and ask, and so you can ask your questions directly to the speakers, but I want to make sure that we're respectful of everyone's time. So we're going to end the conversation here, and we want to thank all of our speakers for coming out today. Thank you so, so much. Beautiful. And we will see you all at the next Context Graph Meetup. And especially if you look on Lumo, we have our next Graph Exchange coming up in March. So we look forward to seeing you all there. Please feel free to connect with us and connect some dots on your graph. All right, we'll see you guys soon and come up with all your last questions. Thanks so much.
Thanks, everyone.